In this section, we will be comparing slopes of different equations. In particular, we cover slopes of parallel lines and slopes of perpendicular lines. There are 4 different cases of slopes. The first case is a positive slope, and this indicates that the line slants up from left to right. On the graph, the red line indicates a positive slope. If we were to look at an example and solve for the slope, we would find something equaling a positive number, such as m equals 3. The next case is a negative slope. That indicates the line slants down from left to right. And on the graph, it is the blue line that indicates a negative slope. An example of this would be m equals negative 1/2. Next, we have an undefined slope. This will be illustrated using the green on the graph. And if we were to have an example, this would be finding m equaling any number divided by 0. This is a vertical line. And lastly, we have a slope of 0, and this is any horizontal line. If we were to solve for m would equal 0 divided by any number a. Next, the slope of a line can tell many things, such as if 2 lines are parallel. If 2 lines have the same slope, then the 2 lines are parallel. For example, we have y equals 3x plus 8 and y equals 3x minus 4. Both of these equations are in the slope-intercept form. This is shown as y equals mx plus b, where m is the slope, this is the coefficient in front of x, and b is the y-intercept. As you can see, y equals 3x plus 8, 3 is the slope for that line. In the next line, y equals 3x minus 4, 3 is also the slope. And since these are equal, we know these 2 lines are parallel. Now, let's do an example. It says determine whether the line through negative 1, 2 and 3, 5 is parallel to the line through 4, 7 and 8, 10. We can tell if these 2 lines are parallel by finding the slope of both lines. By using the slope equation and plugging in the points, we find that the slope of the first line is 3/4. Doing so for the second line, we find that the slope is also 3/4. And since both slopes are equal, we know the 2 lines are parallel. Now, we can also look at the slopes of lines to show whether 2 lines are perpendicular. Perpendicular lines have slopes that are negative reciprocals. This means that their product is equal to negative 1. Lines with slopes that are negative reciprocals are also perpendicular. For the example below, we see that the slope of the first equation is negative 1/3. And the slope for the second equation is 3. To find whether these 2 lines are perpendicular, we multiply their slopes. Negative 1/3 times 3 is negative 3/3, which is equal to negative 1. Therefore, we know these 2 lines are perpendicular. Now let's do another example. Determine whether the following lines are perpendicular. 3x plus 5y equals 6, and 3y equals 5x plus 12. Instead of using 2 points to find the slope of a line, we're going to rewrite each of these equations into slope-intercept form. That is simply y equals mx plus b. So for each of these equations, we're going to solve for y, and after we do so, we can find the slope. The slope is m. It's the coefficient in front of the x. So it's just the number in front of the x. So for the first equation, we have 3x plus 5y equals 6. When solving for y, we see that y equals negative 3/5 x plus 6/5. And the slope here is negative 3/5. It's the number in front of the x. For the second equation, we have 3y equals 5x plus 12. Again, when solving for y, we see that y equals 5/3 x plus 4. To show that both of these lines are perpendicular, we must take both of these slopes and multiply them together to see if their product equals negative 1. So we have negative 3/5 times 5/3. When you multiply fractions, you multiply across. So we have 3 times 5, which is 15, and then 5 times 3, which is 15, and then negative 1 in front. 15 divided by 15 is 1. So negative 15 divided by 15 is negative 1. Therefore, these two equations are perpendicular. Finally, if the slopes of two lines are not equal or do not have a product of negative 1, then the two lines are neither parallel nor perpendicular.